Okie dokie. So, here we get to learn about radian measure for angles. Everything you've seen up to this point probably has been in degrees. Again, the angle starts here and it sort of rotates around the circle this way, so we know that that is about how many degrees? What do you think? About 60? Good. About 90 degrees, 180 degrees, 270 degrees, and all the way around once, 360 degrees. We could go around twice and it would be 720 degrees, and so on. Radian measure is actually, in a way, much simpler, because when we talk about the measure of an angle in radians, it's actually, let me get a wide marker. So here's our angle theta, and if we were to take the length of the arc, I sometimes describe that as the pizza crust. Yum. So arc, and over here we have the radius, and we just take the ratio of those two. So the length of the arc over the radius, we get radians. So that's how we measure an angle in radians. Let's talk about how it relates to degrees, because here we have our unit circle, and we know that if we go all the way around once, that's 360 degrees. Let's think about, if we were going all the way around once, what would that pizza crust look like? Well, it's a whole pizza. There's all the way around. Nice, yummy, big pizza. And if we were measuring that distance, you definitely remember from geometry that the circumference, the distance around, is 2 pi r. So that would be the length of the pizza crust, or arc, and we would be dividing that by the radius. And 2 pi r over r is, you guessed it, 2 pi. So we say that an angle that goes all the way around, or 360 degrees, is 2 pi radians. So here's our equivalency. 360 degrees equals 2 pi radians. You could extrapolate from there. This is 0 radians. Let's see. If all the way around is 2 pi, let's do this first. If all the way around is 2 pi, halfway around, 1 pi. So up top, this is half of 1 pi, and so we call that half a pi, or pi over 2. Half a pi, a full pi, 1.5 pi's, 2 pi. And the 1.5 pi's we call 3 pi over 2. Okay. So that's the intro. Let's look at this in a little more detail. So radian and degree equivalence, because we do have some fractions, and I know people see fractions and they tend to panic, but it's not so bad. Let's start with this. We know that that's pi. So always think about this top section being 1 pi, okay, and then I'm a visual person, so I'm always recommending people to draw stuff and look at it and think about it. But if we were to take that pi and we were to split it into thirds, well, let's start with fourths first. So if we were to take this pi, right, it's just the top part, right? So forget about that. Just the top part. Split it into fourths, nice big yummy pieces of pizza. So each of those is 1/4 of a pi. So 1/4 of a pi, 1/4 of a pi, 1/4 of a pi. And if I were to ask you how many degrees do these angles represent, I bet you could answer, and you'd say, well, that's 45 degrees. Okay, so here we have something that we can keep in mind. Pi over 4 radians is 45 degrees. Notice the 4 and the 4. Yeah. Now let's take that top section. Alright, forget about this. We know the top section is 1 pi radians, and if we were to divide this into thirds, looks something like that. Remember, our little 90-degree line is like this. So here we've divided that into thirds. We have 1/3, 2/3, 3/3. So pi over 3, pi over 3, and pi over 3. And if I were to ask you how many degrees do you think that represents, you'd probably say, yes you would, 60 degrees. So how do we know that? Well, one, when we were drawing our triangles, that kind of looks like 30, 60, 90. But two, what is it that we're splitting into thirds? It's 180 degrees. And you know how to divide. Yeah, you do, don't pretend. So we divide 180 by 3, we get 60 degrees. So we have this other equivalent, and that is that we're talking about pi over 3, that is 60 degrees. And now let me keep that there, because we had that 4 and the 4 coincidence, quote unquote, up top. But let's look at this. Here's pi, and if we're going to divide that into sixths, we get this. So 180 over 6 is 30 degrees. So each of these pi over 6, those are going to be 30 degrees. Pi over 6, pi over 6, pi over 6, etc. So here's a nice generalization, right? Pi over 4, we know it's some function of the 45. And then with the 30 and the 60, it's reversed, but still it's close. So 1/3 of a pi, 60 degrees, 1/6 of a pi, 30 degrees. Alright, and then we could go for multiple. Let's see what we have on the next page. I think we're good here. Oh, and if you need a formula, so I don't recommend this, but I mean sometimes you're going to have a question that says how many radians is 117 degrees, and you just can't do that in your head. So this is how you could actually calculate going from radians to degrees, or going from degrees to radians. Notice how we're multiplying by this conversion factor. You see this in chemistry, you see it in physics, you see it all over the place. But there you go. But let's do this. This is what we're looking for. So, 90 degrees, how many radians? You picture a little circle. 90 degrees is right here. And remember that that's 1 pi, so we got pi over 2 radians, or half a pi. 45 degrees, that was right here. So that's 1/4 of a pi. So we'd say pi over 4. Now 150, ooh, getting tricky. So 150 degrees, it's okay. Let's see, we know that all the way over here would be 180, so it's going to be 30 less than that. So here's our 150 degree, and do you see how we have split? So that is a 1/6. What did I say? A 1/6 of a pi right here. And how many did we have? 1, 2, 3, 4, 5. Yep, 5/6 of a, it's kind of like a tongue twister. 5/6 of a pi, and we write it as 5 pi over 6. 225 degrees. Let's go like this. Save some space. Alright, 225 degrees. So let's see. I'm stressing. 90, 180, plus another 45. Yeah. Alright. So there's our 225 degrees. It's that angle. And what are we doing? Oh yeah, converting to radians. So there's a 1/4 of a pi, and a 1/4, and a 1/4, and a 1/4, and a 1/4. Count them up. 1, 2, 3, 4, 5. So that was 5/4, 5/4 of a pi, which we write as 5 pi over 4. Oh, I switched my color scheme there. You can handle it. Alright, 60 degrees. Here's our circle. 60 degrees is like this. And so do you see how we have split? That's 1/3, and 1/3, and 1/3. So the 60 degrees would be 1/3 of a pi, and we call that pi over 3. And lastly, 180. Oh, we got this. Alright, 180 degrees we know is right here, and this is what we started with. Easy peasy. We know that's pi radians. Okay, so these are equivalent sort of degrees to radians, and if you don't believe me, or you're thinking through these and it's just kind of weird, you might go ahead and use this formula for a bit. For example, 90 degrees, multiply by pi, divide by 180, and you'll get pi over 2. That might help, but I think you got this. Alright, I think we have one more page, and it might be a lot of practice, so get ready. Aha! Just what I was waiting for. So, degrees to radians. The list keeps going. Degrees to radians. So I'll give you radian measure, and you're going to figure out the degree measure. So I'll scroll through them slowly here so that you can try to write them down. But definitely, write this down and try to figure it out before I just tell you the answers. So I got pi over 4, pi over 6, pi over 3, pi over 2, 3 pi over 4, 5 pi over 6, 7 pi over 6, 5 pi over 3, 2 pi over 3, 3 pi over 2, 2 pi, 11 pi over 6, 5 pi over 2, and then the end. So, put this on pause and solve them. Alright, so if you just sat there waiting for me, shame on you. Here it goes. Pi over 4, I'm going to go quickly. Pi over 4 is right here, 45 degrees. Pi over 6, 1/6, that's 30 degrees. Pi over 3, that would be right here, that is 60 degrees. Pi over 2, that is right here, 90 degrees. 3 pi over 4, 3/4 of a pi, that is 45 more than 90, or 135 degrees. 5 pi over 6. So we're breaking that top section into sixths like that. So 5 pi over 6, that would be this angle, and that is, whoops, I'm going to stick with the color scheme here, and that is 150 degrees. 7 pi over 6, so a little more, let's see. We go all the way around, that is 6/6, and then one more. Ooh, not so good, not so good. Back up there. More like, there we go. So there are our sixths. So we have 1, 2, 3, 4, 5, 6, and then 7. So that's a little 30-degree angle, more than 180. 30 plus 180, 210 degrees. 5/3 pi, thirds. So the thirds are these guys, 1, 2, 3, 4, 5, like so. So this is a little 30-degree angle more than 270. 2 pi over 3. I used up all my space. 2 pi over 3. So 2/3. Let's see. Here we go. 1/3, 2/3. So this guy. So that's 30 degrees more than 90. 30 degrees. More than 90. 120. Sounds good to me. 3 pi over 2. What am I doing? Here we go. Half, 2 halves, 3 halves. That's right. 270 degrees. And 2 pi. Oh, I like this one. 360 degrees. 11 pi over 6. What? So notice how that is 1/6 less than, what would this simplify to? 2 pi, yes. So if we break our bottom guy into sixths, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So it's just this 30 degrees less than all the way around. You guessed it. 330 degrees. Are we done? Oh, not quite. Ah, right. So what happens if you keep going? Let's see. 5 halves pi. 1 half. 2 halves. 3 halves. 4 halves. What? 5 halves. That's right. So it went all the way around 360 and then went another 90 degrees. So yeah, that's a big angle, 450 degrees. So occasionally we get things that kind of keep rotating when we talk about applications, and the angle measure will be greater than 2 pi radians or greater than 360 degrees. So there.